Hi everyone, thanks for coming today. My name is Bree, I work in labs, and today we have William from CS8. He is currently working on the Job Me project, which you'll see in a couple weeks once we do demo day, so be looking forward to that. He has hopped into JWTs while working on his project and has gotten pretty passionate about it, so he's going to present and teach us some stuff. So I'm going to hand over the time to William.
Okay, that's me. So, yeah, bear with me. I don't give a lot of presentations, but I was really excited about finally things clicking. So when I was learning how to do authentication and session management, I pretty much stuck to session cookies, cookie-based sessions. So sessions are a thing that you put in a cookie. And so you'll hear a lot of people say, what do you think about JWTs versus cookies? But a JWT can be in a cookie. Or when people say JWT versus OAuth, well, OAuth can and often does use a JWT. So there's a lot of confusion. There's a lot of things that didn't make sense. There are a lot of Medium articles that I read that didn't really seem to quite cover my needs on this. And so I decided I was going to look through the actual RFC, look through the documentation provided by those various technologies and try to pick. It all started with Brian asking me, why are you using that? With like each technology that we were using. I was like, why am I using that? And so I hope this kind of clarifies that, like what are the use cases and vulnerabilities and kind of the problem that it solves, and also kind of an anatomy of it, not just the why, but the how, which is kind of always my fixation as a process-oriented thinker. Okay, so here we go. First thing is, what is a JWT? Or you'll hear people pronounce it JWT, which I can't figure out if I want to do that or not. But a JWT is a JSON Web Token. So it's an open standard. RFC 7519, you'll see that next to specific standards, and you can actually look up the documentation written by the creators. But it says it defines a compact and self-contained way for securely transmitting information between parties as a JSON object. You know, and then there's a little bit more data there, which you feel free to read. This doesn't totally encapsulate what it is for most people, but I just put it in there to kind of introduce, okay, what is it? This is how, JWT.io answers the question. This is the first paragraph you'll read on their website. But I created a little more structured answer. To me, I like to think about what something is in terms of what is it made of. And but a JSON Web Token is just what it sounds like. It's a token that contains a string. We're used to JSON, manipulating JSON. And hold on, my cable got unplugged. Super professional. But it it can be parsed into a JavaScript object. That's what makes it JSON. Is it's an object notation that's compatible with JavaScript. So it's a string, but it contains within it things like brackets, square brackets, curly brackets, etc., that when you parse it, become JavaScript objects. So each token has a header, which just has the type, which is JWT, and a hashing algorithm, like a lot of people use, what's it called? HS256. That one's symmetric. Yeah, or RS256, which is asymmetric. Usually that one's more insecure, especially with less strong keys, but we'll get into the security stuff. The payload, which is just unencrypted, base64 URL encoded, it's a JSON object. Or it's a string that can become an object. So I know that sounds confusing, but Um, every JavaScript compiler handles this. But so why is it base64 URL? Well, base64 URL, if you put a bracket inside of base64 URL, it doesn't stay as a bracket. It becomes something a little bit safer for our uses that we usually have for strings. If you put a quote into it, it doesn't stay a quote. It becomes something else that is URL safe. In other words, if you stuffed it into a place that parses quotes, like JavaScript when it tries to determine whether something's a string, it doesn't break it. It doesn't stop it from being a string. So if you have any familiarity with injection attacks and things like that, you know that they make use of these idiosyncrasies of character combinations to break or hack or otherwise compromise the integrity or access to information. So that's why the payload is, it looks like it's encoded if you're not used to seeing it, or it looks like it's encrypted, but it is not encrypted, it is not hashed. Everything inside of it is completely visible to an end user who can access Google and say, decode base64 URL. The signature, on the other hand, contains the data in the payload hashed using the algorithm in the header. And that is the key to its security feature. So that's kind of the bread and butter of a JSON web token, is it takes what you put in the header, the algorithm, it uses it to hash or encrypt what's in the payload, and uses that to generate the signature. So that verifies the integrity. It's to this extent, it is only as insecure as the practices by which we encode it, where we store it, how we send it over traffic, etc. So a lot of people, you'll hear a lot of vulnerabilities. As much as I've been reading about it, it's hotly contended, but we'll get into that, like I said. So to break it down further, so that you can kind of see this, because I've used a lot of words, but I haven't really shown you. So to the left is an actual encoded JSON web token. And to the right is what's in those three parts. You see that they're color-coded. You have the red space, or the red string, a dot, the purple string, a dot, and then the blue string. And on the right side, you see the objects that correspond to that, as well as the signature, which if we were to fill it in the bottom and click secret base64 encoded, we would be able to generate that signature right there on the fly, because the signature plus the algorithm, that is the hashing, and then it's just applied to the payload. Simple as that. If you go to JWT.io, you can use this debugger for any JWT. Copy it, paste it. It even has an option to pull it from your local storage or from your cookies. It even has a Google Chrome, what's that called, extension. It has a Google Chrome extension that you can use to do this on any site that you're on. It's very informative. I am always curious about looking at what the contents of these tokens are. It's very interesting because, and we'll get into this, the particular use cases for it, especially when you're applying statelessness, when you're putting claims in it that are secure claims because they cannot necessarily be manipulated. You don't have to hit the database to find out everything about that user. You just, anytime you need to know that what they say is true, but you don't need to know, you don't need to deliver them information, you actually don't need to pull up that user. And we'll kind of get into that. So, and this is kind of the segue into that. What do you need to know in order to validate that I am logged in? And the answer is the next slide that I put in the wrong order. But just one thing, you need your index. Whatever that unique value is that your database uses to index the user. So this is not actually a completely stateless application. And some people might criticize this, but I think it's completely valid. And I've seen real world use cases for this. I'm aware of some of the vulnerabilities, And there are some easy mitigation techniques that I don't think we need to be completely scared of using JWTs in these scenarios. But so you can see that I'm doing validify, because the reason I chose that is because MongoDB actually has on its model prototype a validate for, I think it's prop validation. But so that's actually a method that does a bcrypt compare on the schema. And then if password's not valid, let's get them out of the way. That needs a return. But now I'm making a payload. I'm making an object. Very simple expiration const I made, which is just a calculation of milliseconds. Added it to now. The sub field is, this is the index. This is what I was referring to here, is employer._ID. Hey, we found him. It's that easy. And then I put something called user type, which is a little stateless. I have two schemas that are two different users, and I didn't want to hit the database every single time for both. And so this seemed like a really good place to put it, that people could not compromise. Someone couldn't say, oh, hey, yeah, I'm an employer, and really start to mess things up. And so it helped protect routes without having to hit databases first. And so that was really useful. That was I felt like an appropriate use case. And so I'm finding some ways to refactor that might use sessions instead, but it seems at this point like it might be just I think we've already hit the nail on the head for the most part. But yeah, so that's the use case situation. But to double back, what I've done there is I'm the server in the scenario. So they place a post to log in. We encode JWT with the secret and the payload, whatever we put on it. We send those back. Also, it doesn't mention it, but the hashing algorithm is in there too. But you have to, if you don't declare it, either your library or you specifically have to say, I'm only accepting these algorithms. So somewhere it has to say that, because you can always set an algorithm to none and break it and just basically tamper with it. But pretty much every library that you're going to run across does that. But you just want to make sure before you implement JWTs that people can't send signatureless JSON with algorithm set to none and just get a free pass. So, but it returns JWT to the browser, and then it sends it with every request to a protected route. So it just, here's my JWT, here's my JWT, here's my JWT. And the best part is, depending on where you store it and how you preserve it, this will still be valid indefinitely unless you set an expiration either on, say if you use a cookie, you can make the cookie expire explicitly, or you can store it in local storage, but we'll talk about some of the issues with that. But you can always just open that browser back up depending on how you've stored it and send that JWT again. There's nothing inherent about a JWT that makes it expirable. And so I get into that. Expirable user tokens need at least a subfield and an expire field. You can also add any claim you want. In this case, I used user type. I felt that was cutting my database for authentication in half. And oh yeah, and it's easy. Here's my passport strategy. All I do is when people come in, I check to see if they're one user type or if they're the other. And then I choose the schema. I choose the database to hit and return this. In Passport's case, it just puts it on rec.user. Very efficient because then you can manipulate the actual, in the case of MongoDB, you can manipulate the document that's passed through rec.user via this strategy and just call save, update, etc., depending on whatever your use is for it. So it creates, it sends you the document into your routes that you can manipulate however you want. So that's very useful. But it's, again, it's like, what is that, 20 lines, 30 lines of code? and you're validated. And as you can see at the top where it says new bearer strategy, it's actually bringing that in on the bearer auth header. So your authorization headers, you send it a bearer token. It's just that. It decodes it. And then right here, I check if it's expired. 2 lines of code, and now you have an expiration. And that's it. So moving on, this brings me to the security concerns. So you have a set of vulnerabilities. I basically I poured over the OWASP docs for, which if you don't know, OWASP is for web security or for tech security. It's a really good resource, but specifically to JSON Web Tokens, to local storage, which is a very common way of storing JSON Web Tokens, and to just authentication strategies in general. Yeah, and so this was kind of what I came up with. There was also, it all kind of started with one Medium article where someone was showing 5 different vulnerabilities or ways to attack JSON Web Tokens. Really, it was just 2, but drawn out across many, many words. And but the payload is transparent. This is in the docs. This is something everyone knows. It's not really a vulnerability, so much as saying that you know, the sticky notes on your desk are a vulnerability, because if you randomly wrote your password on them, they would become an issue. To the same extent, the payload's not a vulnerability. It's just doing, it's absolutely what it's supposed to do. It's not supposed to hold private things. The algorithm, that bothers me. The algorithm set to none, that issue, you can have an algorithm whitelist and say, and most of them have this built in, or at least exclude none as something possible. I know that JWT and Auth0 or Auth0 JSON Web Token both have that built in. But don't count on your libraries to do stuff like that for you. If that vulnerability arises, make sure that you fix it. It's very easy to base64 URL decode the header and say, if this string isn't present here, then get rid of it. So you can totally, don't hand roll your encryption, but you can definitely make your own validator for whether the header has the right algorithm. HS256, that was the one that's symmetrical. So when you use a weak key, this is not as secure, and it's also, I think, the default for most of these. So use a strong key. That's super important. That's always important. So that's not a particular vulnerability to JSON Web Tokens. Packet sniffing, again, not a particular vulnerability to JSON Web Tokens, but we're all, professionals, and we're using HTTPS. We're not going onto public Wi-Fi's unprotected and just sending validation or authentication of any kind. Cross-site scripting, token theft. If you put it on local storage, it's accessible to JavaScript, which means that XSS is possible. So like if someone had an href or something somewhere to some site that performed some sort of malicious algorithm that swiped your local storage, totally possible. You can mitigate that by using HTTP-only cookies. You can also mitigate it through a lot of other practices, like making sure you don't have multiple apps on the same domain, so that somebody, because local storage is domain specific, so if you don't, it's it's one of those things where it's kind of 6 in one hand, half a dozen in the other, because you have issues of traffic, you have issues of storage, and how those issues overlap or how they compete with one another. You have to think on a more broad level than just, hey, I'm not going to use a JSON Web Token. And but with the last one is indefinite validity, and like I said, include an expiration. You don't want that to just be permanently valid. But yeah, that's really it. Those are the security concerns that I got from OWASP, the ones that I got from the articles about why you shouldn't use them, the ones I got from articles about um, how I hack JSON web tokens. So, but that totally, everything is mitigatable. You can use these safely using practices like these and other ones that you think up for your use case and not feel like you're opening up to a wide world of vulnerabilities. For example, the most common use case is for third-party authorization, and it is happening. Every time you log in with Facebook, Google, etc., with a lot of these websites, it's already something you're implementing. So don't feel like you are treading into new territory just because when you Google who uses JWTs or when to use JWTs, 20 articles pop up that say don't do it. But yeah, I hope this was informative. And if you guys have any questions, I might be able to answer them. Thank you very much.
Hey, thanks so much for the presentation. Does anybody have any questions they want to shoot William over? You can do it in chat, or you can just turn on your microphone. I'll give you like a minute to think about it, so you're not completely on the spot. I think part of being on these Zoom calls and being in an online school, you have to be comfortable with the silence, and it's really painful sometimes.
Right. That's where meditating comes in handy, right?
Yes.
Robert asked, so every part of the token is hashed. I don't know if I answered that question at some point, but no, it is not. It is base 64 URL encoded, which is just a way of preventing special characters from being injected. And it's just a really good way of carrying a string that you want to be usable in all types of code. Yeah, only the signature. The signature, so the hashing algorithm is in the header. The payload is just an object, whatever you put in it. And the signature is the signed portion. That is hashed, and that's the part that your verify or decode or whatever it's called in your JSON Web Token library. That's the part where it checks it. Is it compares your payload to the signature with the secret and the hashing algorithm.
Hey, William. This is Vim. Can you hear me?
Yes.
Hey, thanks for the talk. This was pretty cool. Like a couple questions on like storing the JWTs. I know you mentioned session storage or local storage. I was thinking those two options, or maybe if I was using Redux, I don't know if that would be an option. Maybe that's more, maybe not actually thinking about it. But can you talk a little bit about best practices on where to store it?
Oh yeah, for sure. So Redux is a little bit more opaque just because the library, but if you're using Redux with React, and you're storing it in state, your app will have a store, or there's a series of steps that you can perform in your console to acquire the JWT from Redux. So if you put it in the store, it can be found. Someone could, here's an example, and I just thought up, I don't even know exactly how I'd implement it, but actually I kind of do. So you would, if it was a public repo, you could clone it, npm install it, run it, change things to localhost, figure out how it's set. There's always a way to deconstruct something if it's accessible to JavaScript. Local storage and session storage are both extensions of the web storage API, which is completely accessible to JavaScript. If you look up the MDN docs for web storage API, so both of those are accessible to cross-site scripting. So none of them are completely safe. Really, nothing is, right? But I feel pretty safe with local storage for myself, and for if I was going to use a single app on a single domain, and I had a good check on it, and it expired, and you had some other fail-safe for determining, like, if a user, if that stuff was stolen, if they had a way of knowing that there was a new login from another computer. You've pretty much just completely obliterated the use of cross-site scripting. That's why that's a use case. So if you're using local storage and you wanted to scale an app and really use it, I think, this is me personally, you'd want to include a notification of, you'd want to do it anyways, even if you weren't using JWTs, even if you weren't using local storage, you want the user to know when someone else is trying to log in to their computer. And then when I mentioned HTTP only cookies, the only reason I would preference that is because that's not accessible to JavaScript. Your browser keeps it a secret from that aspect. It keeps it a secret. In the case of Chrome, V8 doesn't ever know about your HTTP only header. It doesn't ever go into all that stuff. So it's something that's sent out when you send the HTTP request. It adds it on at the, like, if you were thinking about it on like an OSI layer model, there's like the highest level, which is your application, and then like the next is like your presentation, I think, and then session. It's like deeper than what's happening in your tab, I guess to say. So that's why HTTP only cookies, which if you're already doing cookies, it's very easy to flag that. It's literally just a flag. Then it won't be something that you can get with document.cookie. So if you go in to your console right now and you hit local storage, just type it and hit enter in your JavaScript console, it all shows up. If you type document.cookie, it all shows up. And those are just a bunch of strings. But if you go in and type document.cookie and it's an HTTP only cookie, it's not there. But it still works. So that's, to me, the most secure way. It is also such a pain, and there are vulnerabilities on the server side that local storage doesn't have. So there's a lot of stuff that you wind up. I feel like you could read books on just that, and I've started to, and I'm already like, okay, I still don't know what the most secure thing is. I just know that I feel, or that from what I know, it feels kind of like 6 in one hand, half a dozen in the other. What I mean by that is, like, I'm from Texas, so maybe that's not something everyone says, but it means like it is kind of a wash. Like, people can like argue with each other about it, but as far as real life vulnerabilities, it's I think sometimes the cost is too high. Like, to have a token and I just send it and you hold it and you send it back, the convenience is so high. So I don't know. To me, that's just opinion. Someone might come and, throw cold water on me for saying that, but I put it in local storage for the labs because I've seen it done in scaled and deployed apps. So it's one of those things. But if you were going to be super tightly secure about it, or if you had a security professional on your team egging you about it, maybe they'd tell you to put it in HTTP only cookie.
Hey, William, this is Robert. I have another question.
Sure.
So one issue that I've heard with tokens is that since they're client side, it kind of frustrates your ability to invalidate them if you have to for some reason.
Oh yeah, definitely.
And so one approach that I've read, because you have to communicate with the browser, and one approach that I've read is that you could store like a blacklist of cookies that you haven't validated in your database and check them, right?
Yes.
Is that the best way to do it, or are there any other approaches you've seen?
Well, I have a couple of problems with that method. Okay, if you have a security vulnerability on one token, I feel like, yeah, okay, you kind of have to bite the bullet and do that. Maybe you could store it on that user. No, you have to. The thing is, now your validation's got to go through checking a whole blacklist. before it can actually get to the process of authenticating. I feel like if you have a fast expiration, like an hour, and then you have a refresh situation set up where as that user is using it, if you get a request from that user within 10 minutes, they get another one, and then it invalidates after an hour of misuse or after an hour of non-use. So they haven't hit your server for an hour, and then the most recent one that they have, that's the one they've got, and now it's expired. And so that to me seems like a really cool way of eliminating the worry about blacklists, because it's just as heavy, but also it doesn't break as easily. It's like you're performing, roughly as many operations, because depending on how often these things get compromised. But to do something like that, like expiration and refresh kind of flow, seems to work really well. And then the other thing I would say is, if you have a lot of issues all at once, like everything's compromised, it's all totally screwed, you can just set a hard-coded invalidation at date.now. Anything from right now earlier is invalid. So to me, that's the big reset of like, nope, no one's allowed in, get a new token, which is what, from what I've read, is it seems to be the common way of invalidating all your tokens. So between those two, and then also a blacklist, you have every solution that you need for that. But yeah, you're right. That's the biggest problem with JWTs as far as using them as kind of a session type thing is, yeah, like the token's still good. Like it's good because it says the true thing. But yeah, I find that so fascinating. But I think that's kind of why I like it. It's very easy to set it up so that someone can just close a tab, open the tab back up. If you're using React, it just checks for whether the token still exists. It's really easy if you put it on local storage. And then it just gets your profile or whatever because you have the token there. I hope that answered the question.
Yeah, I did. Absolutely. Thanks.
All right. Well, you guys are free to message me or something, and if I don't know the answer, it'll just send me on a reading quest. I'm so bent on figuring this stuff out now. So JWT has been my pet project this week.
Awesome. Well, thank you so much for presenting. And like William said, if you have any questions, you can track them down on Slack. So thanks everybody for joining us, and we will talk to you later. Bye.
Thanks, guys.